Today we're going to begin with instructor evaluations, and Pierre and Rashi are going to conduct those. But I'm going to make a couple of comments about the evaluation process before they begin. And I realize that this may be somewhat unorthodox, but I assure you that I have checked this out with student services staff, and it's considered completely appropriate for an instructor to make comments about the process. You should, of course, write whatever you think is appropriate to write, but I want to say a couple of things about the process of anonymous evaluations in general, because they play an increasingly important role in our economy, Yelp, etc. This is like a lot of aspects of our economy, this is a production process, education, in which it's very hard to measure the outputs, right? We can measure the number of grades people get and the number of diplomas they receive, but that doesn't tell us anything about the amount of human capital that was generated. And so in order to monitor the quality of the process, one of the things we do is to ask you for your input. My experience, and I hope you'll forgive me for saying this, is that many undergraduates do not take this process very seriously. And I think that that is irresponsible, and I would like to strongly encourage you not to take this process unseriously, but to take it seriously. And I want to say two things about that, two different dimensions along which I think people fall short. The first is that this is a public good, and like all public goods, it suffers from the prisoner's dilemma. Many people simply don't make the effort. So in this process, and in any other process in which there's a prisoner's dilemma, my first and strongest admonition is that you make the effort, both for my evaluation and for your GSI's evaluation. The second thing is this, and if you spent much time on places like Yelp, sites like Yelp, you'll probably know this, and if you ever become a college or university instructor and get student evaluations, you will see it again. Not everybody who is asked to write down their thoughts anonymously about something do so in a way that is particularly mature. It is sometimes for some of us an opportunity to say things that we would not otherwise allow ourselves to get away with. And so in addition to simply making the effort, I would encourage you, no matter what you have to say, to express yourself in a way that is both intelligent and mature. You'll feel better if you do. And with that, I'll turn things over to Pierre and Rashi. And Thanks very much, guys. No, I ran out for some reason. I don't know what happened. What happened today? I brought 125 copies, as I always do. Where did they all go? Is somebody sitting on a bunch of handouts? Did someone like take a whole stack of them for their sorority sisters or fraternity brothers or something like that? I'm very sorry. You can email me and I'll send you a PDF, or you can, yeah, I'm very sorry. Is there anybody else who doesn't have a handout? Zoiks. Is it just sort of a custom that everybody comes to the last class? There's not 125 people enrolled in the class. So the fact that we ran out of 125 copies is, I don't know what to say other than goodness gracious. Okay, so I apologize for that. I'm not sure I could have predicted that would happen. Okay, so as I've said now several times, we'll have an exam review here on Tuesday at regular class time. So I'll go over the material for the whole course. The exam, roughly speaking, very roughly speaking, will be sort of 2/3 on the material since the last midterm and 1/3 on the material from before that. But more to the point, probably the exam will involve questions that mix material from the whole semester into problems that involve more than one type of model. Okay, the final, as I said before, is next Wednesday at 8 o'clock in the morning. And what you'll see online, if you go to the place where it tells you where to find your exam, it'll say Bechtel Auditorium. And if you then search for Bechtel Auditorium, you'll find that it's not so easy to locate because it's not actually called that. It's called Sibley Auditorium, and it's located in the Bechtel Engineering Building. And fortunately, the engineering folks know this, and so they've got a little place where they say, here's how to get to the Bechtel Auditorium, even though that's not what it's called. I believe it's the case that I will receive a PDF with instructions on exactly how to get there and so forth, and I will forward that to you when I get it. Okay, so... Okay, so we're still talking about behavioral game theory, and we'll go back and touch on the stuff about the n-player stag hunt game, which we missed, which I think is interesting because it's, models of cooperation in games I think are really interesting for anybody who cares about such fantastic notions as the social contract or living together. And then we'll talk about an approach that some folks took to actually testing whether or not the level K model is actually the right model, which I think is a useful way of sort of revisiting some of the different strategies that we've seen over the course of the semester for really getting serious about not just positing a model that might explain the results we see, but actually testing whether or not it's actually correct. And we'll talk a little bit about sort of a grand question that is... we look at a couple of examples of this from game theory, but it's a topic that has much more sweeping relevance. Can irrationality survive amidst rationality? Because here at the end of the semester, we might want to ask ourselves, is any of what we studied over the course of the last 3.5 months of any relevance whatsoever? And there are a lot of economists who will poo-poo without a great deal of thought or consideration or proof a lot of what behavioral economists look at, because they just assume that competition, the rigors of competition will drive irrational agents out of the market, and so therefore irrationality will not have a big impact. And we know what happens when you assume things. Sometimes you're wrong. Okay. Now I just need to get this thing. I finally figured out the right zoom to make the slides stay put. Okay, so going back to the stag hunt game. Right, so two players each independently decide whether to hunt for hare, which you can catch with probability 1 on your own, and there's not much meat on it, or to go and hunt for stag, which requires a collaborative effort for success. Probability if you don't collaborate is 0. Probability if you do is 1. Obviously, you can make the game more complicated. And as we saw last time, there are two Nash equilibria, as there are in so many coordination games, one in which they both collaborate and come out with a nice big half of a stag, and the other in which they don't collaborate and each come out with a hare, which is worth less than half a stag. Nash equilibrium, right, which was either of these things as an equilibrium, doesn't make a prediction, as is so often the case. What about the level K model? And this is where we got to last time. If your player won, it's a symmetrical game, so we can just look at one player. Do you think there's a 50% chance that the other player will go after the stag and a 50% chance that they'll go after the hare? So the utility of going after the stag is 0.5 times 1 plus 0.5 times 0, which is just 0.5. Meanwhile, the utility of going after the hare, right, which is independent, you basically take yourself out of your opponent's hands. Your fate is no longer tied to theirs, and you can just go and have a hare for X utils. And so the prediction of the model is that you'll see cooperation, right, because it's symmetric. Both players are making the same calculation. I'm sorry, I'm sorry, I sort of jumping ahead. These are level 1 players. We're ignoring level 0 players, as will be often the case with the level K model. And so basically a level 1 player will go after the stag if the hare is very small, and will not be willing to take the chance on cooperating on the stag if the hare is fairly large. Yeah? Makes sense. And you can easily imagine how this would generalize to a lot of collaborative efforts in which people have a bailout option that's not as good as half the payoff from collaboration. And then because the level 1, right, so level 1 says that either of these things could be a predicted outcome, not necessarily equilibrium, because this is a non-equilibrium model, but a predicted outcome, but we now know exactly when each one will take place. And because those outcomes are both Nash equilibria, what that means is that any level above level 1 will also play the same equilibrium based on the same cutoff rule on the size of the hare, right? So this model not only makes a prediction, but the prediction that it makes captures an intuitively compelling comparative static, which is that whether or not you cooperate depends upon the sort of marginal benefit in expected value of doing so. Then we can take this a step further and see whether or not we can actually capture another useful and intuitively compelling comparative static. So it turns out that in lab experiments, cooperation goes down as group size goes up, right? So if it takes the whole class to catch a stag, and one person saying, I'm not up for it today, I'm going after a hare, would completely undermine the stag hunt, then you can see that leaving the level K model aside, it's fairly intuitive to imagine that more people would think, this isn't really worth it. The chances that every single person in the room is going to go after the stag are lower the more people there are in the room. Okay? So it turns out that if you have n players, where n is greater than 2 and potentially much greater than 2, there are still only 2 Nash equilibria, which are that everybody goes after stag, or everybody bails out and goes after a hare. Nothing else is a Nash equilibrium. Here's the deal. If everybody cooperates, then you're better off cooperating too, right? Because if everyone else is cooperating, your share of a stag is still going to be bigger than getting a hare by yourself. And if even one person defects, then it's better for every single other person to also defect. So there can be no Nash equilibrium where some people go after a stag and some people go after a hare, because all the people who go after the stag should have gone after the hare. Okay, so once again, Nash doesn't predict which equilibrium will be chosen, and so naturally it can't predict the effective group size, right? It's not even worth investigating whether Nash can predict the effective group size because it can't predict anything. What about level K? Now, what we did before is we said that the opponent, if you're player 1, then player 2, is randomly choosing between going after hare and going after stag, and so the chance that they'll cooperate is 0.5. If you have two opponents, and each of them is independently randomizing between going after a stag and going after a hare, the probability that they will both go after the stag is 0.5 squared, right? And with n other players, the probability that all of the other, sorry, the probability that, okay, this is wrong. That should be n-1, shouldn't it? Doesn't affect the result. I apologize for that. The probability that all other players will play stag is 0.5 times n-1, right? And what that does is it changes this cutoff rule, right? It says the bigger the group, the lower the threshold for defection. Okay? It's optimal to cooperate if x is less than 0.5 times n to the minus 1, and if n is greater than 2, that number is smaller than 0.5. So basically, a smaller and smaller hare will seem like a good alternative to taking a chance on the whole group for level 1. And then, again, because either everyone cooperates or everyone defects or both Nash equilibria, every level of player above level 1 will do the same thing. So this cutoff rule is robust to the level of sophistication in the population. Now, this doesn't prove that level k is the right model to explain the stag hunt. It proves that it's a model that can explain the stag hunt, right? It's entirely possible that some clever person could come up with a perfectly rational model that would predict these same comparative statics, and though I don't know of what that model would be, the fact that it's possible suggests that it's been done, right? That's the $20 bill on the sidewalk rule. You guys all know the $20 bill on the sidewalk rule? Two economists are walking down the street, one of them looks down and says, look, a $20 bill. And the other one, without even looking down, says, it can't be. If it was, somebody would have picked it up. Yeah? You think that a trembling hand perfect equilibrium could capture it? I'm willing to give you the benefit of the doubt. If you write down the model, I'll take a look at it. Okay. The point I want to make here is simply that, once again, as has been the case in so many other situations we've looked at, adding one dimension of psychological realism, which is intuitively compelling,